Greetings of the day, everyone. I'm Dr. Rohit. I'm going to talk about Kruskal Wallis tests. Just like a brief introduction about non parametric tests, basically, these are tests that do not make any assumptions about probability of distribution of the variables being assessed, also called distribution free statistics. You know the stories. You have tried for hours to normalize your data, but you cannot. Even if you can, your variances turn out to be unequal. But do not be in dismay. There are statistical tests that you can run with non-normal data. All of these tests that we have read so far, such as t-tests, ANOVA, rely on comparison with some probability distributions such as a t-distribution, f-distributions, and that's why these are known as parametric statistics, as they make inferences about population parameters. However, there are statistical tests that do not have to meet such assumptions, and they are known as non-parametric tests. Many of these tests are based on ranks and/or comparisons of sample medians rather than means as means of non-normal data. Non-parametric tests are often not as powerful as parametric tests, so you may find that their p-values are slightly larger. However, if your data is highly non-normal, non-parametric tests may detect an effect that is missed in equivalent parametric tests due to falsely large variances caused by the skewness of data. There is, of course, no problem in analyzing normally distributed data with non-parametric tests also, but non-parametric tests are equally valid, and most have been as long as around the parametric counterparts. Now let's coming on to the non-parametric equivalents of the parametric tests. We are going to focus on Kruskal-Wallis test. The parametric equivalent is one-way analysis of variance. Kruskal-Wallis tests. We use a Kruskal-Wallis test when k is more than 2, that is the number of independent samples is more than 2. In such settings, we can use Kruskal-Wallis test when the assumptions for parametric tests are not satisfied. Kruskal-Wallis test is a general test to compare multiple distribution and independent sample. The idea behind the test is to determine if k population seems to be same or different based upon the ranks of the value instead of the magnitude. Ranking procedures are commonly used in non-parametric methods as this moderates the effect of any outliers. Test assumes identically shaped and scaled distribution for each group except for any differences in the median. The steps involved in doing the tests: first we state the hypothesis. The hypothesis basically is that the null hypothesis is the medians of all groups are equal, and the alternate hypothesis is that medians are not all equal. We come to step 2. Now we have independent random sample from our k population. All observations in each sample must be independent of all other observations. We have an ordinal, discrete, or continuous response variable. We assume that there is only a location shift, so we should check that the distribution are similar except possibly for their locations. The data are summarized by test statistics, which involves ranks of observation in each group. To rank the observation, we combine all observations in all samples and rank from smallest to largest. Then we determine the ranks, which comes from which sample, and then use this to obtain test statistics. Step 3 is to find the p-value by using test statistics. We rely on software to obtain the p-value for this test. And the step 4 will be conclusion in terms of median in the k population, or in terms of existence or non-existence of a relationship between the independent variable and the dependent variable. Thank you so much.